This is the first session on matrices. Numbers are used to give information on quantity. Matrices can be used to give information of two or more quantities, such an occasion given below. We'll see what this says. Numbers are used to give information on quantity. Now think about if you need to identify some quantity just by measuring some quantity. It is quite like measure of height of an student. Then what you can do it, you can measure the height of the student and you can represent it using a number. If it is 152 centimeters, likewise you can say that it is just a numbers. And if you are asking for number of students in the classroom, number of students, then we can have it as 90. Then again we can use the numbers to represent a quantity. But sometimes you need to deal with more than two quantities or more than one quantities. Actually, it is two or more quantities. Then in such situations, we can apply the concept of matrices for such explanation. Here you can see an example given. According to this example, it says that there are three students in a class and they have got prizes for their performances in the examination. If we look on the prizes of these three students, then we can see that A has got a prize, then B had got a prize, and C also got a prize. If you see on the prize of the student A, in that prize, we can see that there are exercise books and pens. There were 6 exercise books and 3 pens. If you see on the prize got for student B, there were also exercise books and pens. If you see on the exercise books and pens, there were 4 exercise books and 2 pens. And if you look on the prize got for the student C, that student has got 3 exercise books and no any detail regarding the pens. There were just 3 exercise books. Therefore, we can assume that there are 0 pens. It is because there is no any evidence regarding mentioning on the number of pens. Therefore, it will be 0 pens. Therefore, in a situation like this, what we can simply do is we can simply apply, show these data using a table. Therefore, if you can draw a table in the first one, we can say first column, we can say that student name in the first column. And here we can, in the second column, we can say that number of exercise books we are having. And in the next column, we can say that it is the number of pens in the parcel. Then for the student A, B, and C, we can write down their number of exercise books and number of pens in their parcels respectively. Therefore, for the parcel got by student A, 6 exercise books and 3 pens. Likewise, we can say this as 4 and 2, 3 and 0. This is how we are representing the data in the tabulated form, or using a table we can show this data. And if you select these numbers, then the arrangement of these numbers can be written in this form also. It is just as 6, 3, 4, 2 and 3, 0. And if you can write inside this as inside the parentheses or the box brackets, then this type of arrangement is said to be a matrix. Therefore, this is how we are forming a matrix. Then the tabulated values can be represented using a matrix. Now we will see that here this is given for just how to use a matrix to show the quantities. Therefore, if you see on the first row, it is for the details on the student A. Here it is for the student B. Here this is for student C. This is for the number of exercise books, and in this next column it says the number of pens. Likewise, it is fine. Just a table Here we have represented using a matrix. Now we will look on a definition of a matrix. We will see what is the definition for a matrix. A matrix is a rectangular array of numbers. If the array has m number of rows and n number of columns, then it is said to be a m by n matrix. The number of m and n are called as the dimensions of the matrix. This is what we are saying as a how we are defining a matrix. It is the general form of defining a matrix. Therefore, if you look on this definition, it says that matrix is a rectangular array of numbers. Therefore, we can write, since it is a rectangular shape, it may be in this form or else in the other way around. Therefore, this is the general way that we can see the arrangement of numbers in a matrix. Therefore, if you see on the previous one, it goes just as 6, 3, 4, 2, 3 and 0. If you draw a shape on this, what you can get is here, if you are connecting these numbers, then you can just get it as a rectangular. The shape is rectangle. Therefore, this can be considered as a rectangular array of numbers. Then what we can see on this rectangular array of numbers is, if you are writing a rectangular array of numbers, there should be a finite number of rows and finite number of columns. In a situation like this, the example that we have taken was 6, 3, 4, 2 and 3, 0. Here I told you that we are using parentheses to write this, and here we can see that number of rows equal to 3, number of columns equal to 2. 3. Here we can see that there are 3 rows and 2 columns. That is how we are defining this matrix. Therefore, in general, we can say that matrix is a rectangular array of numbers. Then it says that if the array has m number of rows and n number of columns, then it is said to be a m by n matrix. Okay, without using this m and n, if I use these numbers for number of rows and number of columns, here we can see that there are 3 rows and 2 columns. Since there are 3 rows and 2 columns, we can say that this matrix is a 3 by 2 matrix. We are not going to solve this and say this is equal to 6. We are not going to do this calculation. This is just we are using this as a notation only. We are not performing any mathematical calculation just by multiplying 3 into 3 by 2. Here we are just using this as a notation only. Therefore, if you see this notation, we know that this notation stands for the dimension of the matrix, dimension of matrix, or in other words, we can say this as the order of the matrix. This is said to be the order of the matrix as well. We can say it is either the dimension of the matrix or the order of the matrix. Therefore, if you are as soon as you are writing a matrix, then here we can see that 3 rows and 2 columns. Then we can write down the order of the matrix in this form. Here it is a 3 by 2 matrix, 3 rows and 2 columns. Therefore, this is said to be a 3 by 2 matrix. Then if we extend this matrix into m number of rows and n number of columns, it is quite like this. Now think about if you are taking an matrix in this form. Here you may have some values, and likewise you may have several values. Then if you see the number of rows, here it is 1, 2 coming up to m number of rows, and here it is going up 1, 2, likewise goes up to n number of columns. Therefore, if your matrix has m number of rows and n number of columns, then we can say that it is the dimension of the matrix. The dimension of the matrix will be equal to m by n. M multiplied by n is said to be the dimension of the matrix. Generally, we are writing the dimension or the order of the matrix in the bottom right corner of the matrix. Generally, we are writing the dimension in the bottom right corner of the matrix. Here, this is an example, the same example which I have taken as well. 634230 denoted as a matrix, and here we can see that dimension of the matrix as given as 3 by 2. Therefore, we can say that the matrix contains 3 rows and 2 columns. Now we will see on the notations of a matrix. Matrices are commonly written in box bracket or parentheses. Here what we have written so far is as well. Here if we are writing a matrix, we can write these numbers 634230 inside the parentheses. Here we can say it is 3 by 2. If I write this again 634230, then I can write it inside the box brackets as well. Here it is also 3 by 2 matrix. Then we can say that we can use the parentheses or box brackets to denote a matrix, write down a matrix. Then we can say that matrices are usually symbolized using uppercase letters. Then if you write a matrix, then we should give a name to this matrix. Therefore, we can name this matrix using an uppercase letter. Here I can say it is as the letter A. In English, uppercase letters are generally using to naming the matrices. Therefore, we can say that matrix A is a 3 by 2 matrix having the elements as 6, 3, 4, 2, 3 and 0. And if I write this matrix, then I can say this as matrix B, 6, 3, 4, 2, 3, 0 likewise. We can just use the English uppercase letters to name a matrix. But in some situations, rather than using these numbers are said to be elements or the entries of the matrix. Therefore, rather than saying these as numbers, we can say that these are the entries or the elements of the matrix. But in some situations, we may see that once you are naming the matrix in the uppercase letter A, then you can see that sometimes the elements are shown as the letters, not as the numbers, just as the letters. If the elements are showing as letters, then we have definitely use the lowercase letters to denote the entries or elements. Here we can see that we can say it as PQRS. If I write down another matrix here, if it is as B, then we can say that it is ABC. Here I am saying it as the PQR and XYZ. Here there are 9 elements. This is a 3 by 3 matrix. This is a 2 by 2 matrix. Therefore, generally we are using the uppercase English letters to name the matrix and lowercase English letters to write down the elements of the matrices. This is the general notations we are using to denote the matrix. But in some situations, in the previously I told you on this, if we are having, we may have to use the numbers to represent the elements, as well as we can use the letters to represent the element. Here I have used several letters to represent the elements. But in some situations, if the matrix is named as this A, then lowercase letter is used to represent the elements, including the row and column numbers. This is another technique that we can use to name the elements of a given matrix. Therefore, if we are naming the elements of a given matrix, here we can see that if we are having rows and columns here, these are rows in the matrix. We are considering here these are the columns in the matrix. So if you name the rows, then this is the first row, second row, likewise we can say this as the mth row. If you name the columns, this will be first column, second column. Likewise, we can move for this would be the nth column. Now, if you name the element including the row number, then we can say this element would be the element in first row, first column. Therefore, we can name this element as A11, where this A11, the first digit shows the row number. Here, the first digit shows the row number and second digit shows the column number. Second digit shows the column number. Therefore, using this concept, we can name the next element. Here it is in the first column, first row, second column. Likewise, we can move for first column, first row, nth column. Then, since we have finished the first column, then we will move for the second column. Then this will be A21, second row, first column element. Then element in second row, second column. Likewise, we can move for the second row, nth column. And if you suppose that there are m number of rows in this matrix, it would be now AM1, element in mth row, first column. Then AM2 will be element in mth row, second column. Likewise, we can say that this would be the element in mth row, nth column. Mth row, nth column. And since there are m number of rows and n number of columns, we can show this as a m by n matrix. So the dimension of this matrix will be m by n. And in the next example, it is just the only difference between this example and this would be just, instead of using box brackets, I have used the parentheses here. Therefore, all the other concepts are same. Therefore, I'm not going to repeat this part for this part. And here we can see that we are using the numbers for the first digit for row number and second digit for column number. Therefore, this matrix can be reduced in this form. Here we can see that this is a collection of elements in the form of Aij. Here we can say that the order of this matrix is m by n, and we can say that if you see on the possible values of I and j, where I goes from 1 to m, 1, 2, 3 up to m, I is the row number, and j goes from 1, 2, 3 up to m. Therefore, this is how we are denoting the row and column numbers. Then we can represent this element as the common way. It is Aij, where I is the row number, and j is said to be the column number. Therefore, this is how we are writing a matrix using the notation. And this says that where the I is the row number, j is the column number, and this correction has to be made. Here we can use the Aij. It is lowercase letters Aij to represent the entry in the ith row and jth column of matrix. This is for the definition and the notations of a matrix. Now we will discuss on the types of matrices. When we are going to discuss on the types of matrices, according to the nature of the number of rows and columns, as well as for the nature of the elements of a matrix, we are identifying several types of matrices. The first type that we are identifying is the null matrix. We will define first what is null matrix. Null matrix is said to be a matrix having all elements as zeros. If you can see a matrix having all the elements as zero, as an example, if I say matrix A, if you can see all the elements of this matrix are zeros, then this is a 2 by 2 matrix. Then we can say that A is a null matrix. A is a null matrix, or we can say that A is a zero matrix. We can say whether A is null matrix or zero matrix. The only thing is, we need to, if we can identify all the elements of null, all the elements of a matrix as zeros, then we can say such matrix is a null matrix or zero matrix. Here another example is given. Now you can see according to the example given here. This is a 2 by 3 matrix. We can see that all the elements are zeros. Therefore, we can say that B is a null matrix. Another name for null matrix is the zero matrix. Therefore, you can say that B is a null matrix, or else we can say that B is a zero matrix. The next type of matrix is the row matrix. The next matrix type is the row matrix. If you can see just one row in a matrix, then such matrix is said to be a row matrix. If you can see a matrix in this form, suppose that A has only one row having 1, 5, 2, then you can see that there is only one row and there are several columns, so 1 by 3. Then we can say that A is a row matrix. A is a row matrix. Another example, if you let B equals 1, 5, minus 2, 7, then it is 1 by 4 matrix. Since you can see there is only one row here, we can say that B is a row matrix. Therefore, if you can see just one row in a just one row only in a matrix, then we can say such matrix as a row matrix. Then the next type of matrix that I'm going to discuss here is column matrix. The next type of matrix is the column matrix. When we are discussing on the row matrix, we have discussed that if a matrix has only one row, then such matrix is said to be a row matrix. If we are having only one row, then such matrix is said to be a row matrix. Now, if we can see there is only one column in a matrix, then such matrix is said to be a column matrix. Therefore, a matrix having only one column is said to be a column matrix. Here we are having 1, 2, and 5. We can see that there are 3 rows but only one column. Then we can say that A is a column matrix. A is a column matrix. Another example, if we are considering that B as minus 2 and 5, then we can say this is a 2 by 1 matrix. Here also we can say that there is only one column. Then we can say that B is a column matrix. Then therefore we can say that if a matrix has only one column, then such matrix is said to be a column matrix. Now we will move for the next type of matrix. It is the square matrix. The fourth type of matrix that we are going to discuss is square matrix. If you can see equal number of rows and columns of a matrix, then such matrix is said to be a square matrix. As an example, if you have this, here you can see that here it is 5 minus 2, 7 and 1. Here you can see that there are 2 rows and 2 columns. In generally, we are saying that matrix is a rectangular array of number. Actually, if you look on the shape of the rectangle and square, actually the square is the special case of this case of a rectangle. If all the four sides are equal, then such rectangle is said to be named as a square. Therefore, using that concept here also we can say that even though matrix is said to be a generally matrix is said to be a rectangular array of numbers, here we are defining this matrix as a square matrix since we can see equal number of rows and columns in this matrix. Another example here we can say that therefore we can say A is a square matrix. If you are having three rows and three columns like this, let B be a matrix having 1, 3, 5, 6, 9, 0, minus 2, 7, and 8. If you can see this type of matrix, which is having it as a 3 by 3 matrix, then here also we can see that there are 3 number of rows and 3 number of columns. Then we can say that B is a square matrix. B is a square matrix. Therefore, if you can see equal number of rows and columns in a matrix, then such matrix is said to be a square matrix. Then we will discuss on the next type of matrices. It is the diagonal matrices. The next type of matrices we are going to discuss here is the diagonal matrices. If you see the explanation for the diagonal matrix, a diagonal matrix is a matrix having non-zero elements, only in the diagonal running from upper left to the lower right. Before discussing on the diagonal matrix, we'll see on this matter also what is meant by a diagonal of a matrix. Actually, we are defining these diagonals only for the square matrices. We are not going to defining this for the rectangular arrays. Only for the square matrices, we are defining these diagonal matrices. Therefore, we can say that every diagonal matrix is a square matrix. Therefore, this is the next important thing. If you can see a diagonal matrix, then definitely that diagonal matrix should be a square matrix. Otherwise, we may not get exactly the numbers on the main diagonal. And if you look on what is meant by the main diagonal is the diagonal running from the upper left. This is the upper left of the matrices to the lower right of the matrix. And this is said to be the main diagonal of the main diagonal of the matrix. And now if you see what is a diagonal matrix, diagonal matrix is said to be a matrix which having non-zero elements, only on the main diagonal. It says that the remaining elements which are said to be the off diagonal elements, then they should be all zeros. It is quite like this. Now, if you are having a 2 by 2 matrix, if this is a 2 by 2 matrix, and we can identify this is the main diagonal. If this is the main diagonal, then we can identify the element at this point, and element at this point will be the elements on the main diagonal. Apart from the elements on the main diagonal, others should be equal to 0. Therefore, if you can see 2 zeros here, then if you let this as the matrix A, then this is naming as a diagonal matrix. Here I will say this is 1 and 2. Then we can say that A is a diagonal matrix. Another example for the diagonal matrix, if you say B is a matrix in this way, 1, 0, 0, 0, 3, 0, 0, 0, and 7. If you see on this matrix, a 3 by 3 matrix is defined, and if you find out the main diagonal of this matrix, You can see that it is running from the upper left to the lower right. You can see that all the off diagonal elements are now zeros. Therefore, we can say that this is a diagonal matrix. This is a diagonal matrix. It is because all the off diagonal elements or the elements which are not on the main diagonals are zero. Then we can say such matrix as a diagonal matrix. And if you discuss on the diagonal matrix, based on this concept of the diagonal matrix, we may be able to find out the triangular matrices. Therefore, based on the concept of the diagonal matrices, we are defining the upper triangular matrices and the lower triangular matrices. Therefore, before defining these upper triangular matrices or the lower triangular matrices, first we need to check whether it is a diagonal matrix. First we need to identify this diagonal matrix. Therefore, using this concept, we can identify this upper triangular and lower triangular matrix. If you look back to the diagonal matrix, it is quite like here it is 1 0 0 0 3 0 0 0 7. Here we can see that all the values which are not on the main diagonal, all the values which are not on the main diagonals are now zeros. Therefore, we can say this type of matrix as a diagonal matrix. This is said to be a diagonal matrix. And now if you see on this case, now you are having a matrix in this form. Now see here it is 1 5 3 0 . If you see a matrix on this form, for all these cases we are discussing this matter for square matrices only. We are not going to define this for any rectangular array of number. Since this is the main diagonal, and if you can see all the elements below the main diagonals are zero, all the elements below the main diagonal are zero, then such matrix is said to be a upper triangular matrix. It is based on the main diagonal. We can say whether the elements below the main diagonals are zero. We can see all the elements below the main diagonal are zero. Then we can say this as an upper triangular matrix. We can say this as an upper triangular matrix. And using the same concept, we can define the lower triangular matrix as well. If you are going to define the lower triangular matrix, it would be probably in this way. It would be 1 0 0 7 5 0 9 2. Here, if you draw the main diagonal, then we will get the main diagonal in this form. Now we can see that all the elements above the main diagonal are now zeros. All the elements above the main diagonal are now zeros. Therefore, we can draw the rectangle in the lower part of the matrix. Therefore, we can say this is a form of the lower triangular matrix. This is said to be a type of lower triangular matrix. Therefore, based on the concept on the main diagonal, we are defining the upper triangular matrix or lower triangular matrix. Now, if you look on this matter, now suppose that you are getting a matrix in this form. Here it is 1 0 0 0 3 9 5 3 0 9 2 5. If you ask to say whether this is upper triangular or lower triangular or none of this, what you have to check is first draw the main diagonal. First, draw the main diagonal and see the elements above and below the main diagonal. Here we can see that all the elements above the main diagonal are 0. But here also we can see a 0, but there are some other non-zero elements as well. Therefore, we are not going to worry on this single 0. Then we can say, since all the elements above the main diagonal are 0, then we can say this matrix is an matrix is a lower triangular matrix. This is also an example for lower triangular matrix. It is because we can see all the elements above the main diagonal are zeros. If you look on this case as well, if you see on this case, now we can see that if you draw the main diagonal in this way, now you can see that there are all the elements below the main diagonal are 0, and only some elements are zeros above the main diagonal, but others are non-zero elements. Therefore, since we can see at least one non-zero elements in the upper part, then we can just say this as a upper triangular matrix. This is also an example for upper triangular matrix. This is how we can identify the types of upper triangular, lower triangular, and the diagonal matrices. And now we will move for the next type of matrices. The next type of matrix that we have discussed here is the identity matrix. Identity matrix is actually a special type of a diagonal matrix. In the diagonal matrix, we are defining it as if we can non-zero elements only on the off diagonals. Here we can see that the main diagonal elements are non-zero, only main diagonals, and all the others are zero elements. And this is a 2 by 2 diagonal matrix. And if you look on this pattern, here it is 1, 0, 3, 0, 0, 0, 5, 0, 0, 0, 2. Here also we can see that this is a 3 by 3 diagonal matrix. It is because the elements which are from as the off diagonals are zeros. Therefore, we can see some non-zero elements on the main diagonal only. Therefore, we can say that this is also a 3 by 3 diagonal matrix. And I told that identity matrix is a special case of diagonal matrix. It is because we can say this as a identity matrix. Here we can see that all the elements are at the off diagonals are zero elements, as well as all the elements in the main diagonals are ones. If all the elements on main diagonals are 1 and all the others are zeros, then such are said to be an identity matrix. Here we are using the letter I to denote the identity matrix. Generally, we are writing the matrix using the English uppercase letters. But when you are writing the identity matrix, we are writing the order as well. Here we can see it is a 2 by 2 matrix. Therefore, we can say this is the I2, second order identity matrix. It is as the I2 and it is given as 1, 0, 0, 1. The thing that we have to keep in our mind is the main diagonal elements are ones and all the other elements are zeros. If you construct the element for I3, this is the third order identity matrix. Therefore, we can see that the number of rows and columns should be equal to 3, and the main diagonal should be have the elements as ones, and others should have the elements as zeros. Likewise, if you construct I4, then we will get this as 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0 and 1. Therefore, this is how we are constructing 4 by 4 identity matrix, or which is denoted as I4. And here, if it is an mth order, here we can say this is the order of the matrix, and this is the denote for the identity matrix. This I stands for the identity matrix and M stands for the order of the matrix. Therefore, if you construct the I of order M, then we can say 1 is here. Likewise, we can go up to M number of columns. And here 1, 0, those are zeros. Likewise, you can say here this is M number of rows as well, and here we will have 1. It is because main diagonals are only ones and others are zeros. This is a M by M diagonal matrix. The next type of matrices that we are going to, this is the last type of matrices we are going to discuss for this section. It is the equal matrices. Equal matrices are said to be the matrices which are having equal number of rows, equal number of columns, as well as the equal corresponding elements. If all these three conditions are satisfying, then such matrix is said to be a equal matrix. It is quite in this form. If we can say that A is a matrix having the elements A, B, C, and D, and we may let P is a matrix having P, Q, R, and S. Here we can see that this is a 2 by 2 matrix. This is also a 2 by 2 matrix. If you say that A and P are equal matrices, if A and P are equal matrices, then if A and P are equal, then the first two conditions are now satisfied. It is because number of rows are equal, number of columns are equal. Then we can say, since these are equal matrices, corresponding elements should be equal. It means the element on first row, first column should be equal to the element of first row, first column. It is quite as A equals element P. Likewise, B and Q should be equal. C and R should be equal, and then D and S should be equal. Therefore, if these two elements are equal, then we can say that corresponding elements are also equal. In the other way around also, if these three conditions are satisfying, then we can say that these two matrices are equal matrices. But in a case like this, suppose that A is a matrix having 1, 3, 5, 2, and matrix B is having 3, 5, 2, 1. Here we cannot say that these are two equal matrices. If you check on the first condition on the rows, it is the number of rows, it is equal, first condition satisfied. If you let on the second condition, it is the number of columns, it is also satisfied. The third condition is not the elements, it is the corresponding elements. Corresponding elements, that condition is not satisfied. Therefore, we can say that A and B are not equal matrices. It is because if you see on the corresponding elements, what it says, if these should be corresponding elements, the element in first row, first column should be equal to the element on first row, first column. At the very beginning, we can see that these two are not equal. Therefore, at the initial stage, we can say that corresponding elements are not equal. Therefore, we can say that A and B are not equal matrices. Therefore, to be equal matrices, all these three conditions should be satisfied, though which are said as Each matrix should have equal number of rows. Each matrix should have equal number of columns, and the corresponding elements of each matrix should be equal. If all these three conditions are satisfying, then we can say such two matrices are equal. And in the other way around, if two matrices are equal matrices, then all these three conditions will be also satisfied. And now we will move for the next part. It is the matrix operations. The matrix operations. When we are discussing the concepts on algebra, for the algebra, we may have the operations as the addition, subtraction, multiplication, and division. But once you come for the matrices, generally we are focusing on addition on matrices, subtraction on matrices, and multiplication on matrices. We are not going to consider on the division for matrices. Divide a matrix by another matrix will not be discussing here. In such situations, we are having therefore only condition we may have the division is just dividing a matrix by a scalar. We will just focus on dividing a matrix by a scalar only, not by division of any two matrices. If we are going to consider on the first arithmetic operation on matrices, it is the matrix addition or addition of two matrices. If you focus on this matrix operation, two matrices can be added if and only if they are of same order. A matrix of the same order is obtained as the sum of two matrices by adding the corresponding elements. If you see on this clause, what we can see is here we can say that if you let two matrices A, B, C, D may be the elements. Here I am letting B is a matrix having the elements P, Q, R, and S. If you need to add these two matrices, the first condition that should be satisfied is the order of the matrices. It means that the order of these two matrices should be equal. Here we can say this is a 2 by 2 matrix, and the order on matrix B is also same as the order of the matrix A. Therefore, order is 2 by 2. Here also we are having the same order. Then if you are having the same order matrices, then we can add the corresponding elements. And by adding the corresponding elements, we can get the summation of these two matrices, and the resultant matrix is also same as the order of the initial matrices. Therefore, if you let A plus B is the matrix C, then we can say that C is also having the order of 2 by 2. Therefore, C should be a matrix having the elements. It is also should be a 2 by 2 matrix. It is because the order of the initial matrices are 2 by 2. Now we'll see addition of two matrices, and prior to that, if you can add two matrices, then we are saying that those two matrices are confirmable for matrix addition. It means that if the order of these two matrices are equal, another example, if you say that A is A, B, C, D, E, F, this is a 2 by 3 matrix. And if matrix B is given as PQR U, this is also a 2 by 3 matrix. Now we can see that order of A is Order of matrix A is 2 by 3. Order of matrix B is also 2 by 3. Therefore, A and B, we can say that A and B are confirmable for matrix addition. Therefore, we can identify this condition. These two matrices are confirmable for matrix addition if they are having the same order. Once you add these two matrices, we will get a matrix C in the form in the order of 2 by 3. It should be similar to the order of the initial matrix. To obtain this result, what we have to do is we have to add the corresponding elements. Therefore, if we are going to add the corresponding elements, then what will we get here? For the matrix C, we can add the corresponding elements together. The corresponding elements in this place is A and P. Therefore, we can add the element A with element P. Then element B and Q can be added together. B and Q are added together. Likewise, C and R adds together. Then D and S adds together. Here we can see that this is a 2 by 2 matrix. Likewise, in here we can say that matrix C. If this is matrix C, then we can say that this matrix C can be obtained as by adding the corresponding elements. First one is A plus P. Next one is B plus Q. Third one is C plus R. Likewise, D plus S, E plus T, and F plus. Then we can say this is a 2 by 3 matrix. This is how we are performing the matrix addition. And if you see on the examples using the numeric values, the first example says for matrix addition as if A is given as 2 by 2 matrix having the elements as 2, 4, 1, 3. Matrix A having the elements 2, 4, 1 and 3. 2 by 2 matrix. And matrix B is given as 3, 2, 1, 0. 3, 2, 1, 0. Another 2 by 2 matrix. Now we are asked to find the value for A plus B. What is the value of A plus B? First, we need to identify whether these two matrices are confirmable for matrix addition. As soon as we see the order of the matrix A and matrix B, we can see that the order of matrix A and B are equal. Since we can see the equal orders of these two matrices, then we can say A and B are confirmable for matrix addition. Therefore, if you add these two matrices A and B, then this would be 2, 4 with 1, 3. And then this is added to 3, 2, 1 and 0. Therefore, now what we can do is we can add these two matrices together by adding the corresponding elements. 2 and 3 is added together. 4 and 2 added together. 1 and 1 with 3 and 0. Therefore, once you perform this calculation, you will end up with 5, 6, 2 and 3. 5, 6, 2 and 3. This is a 2 by 2 matrix. And if you see on the second example, the second example says that matrix A is matrix having 2, 8, 3 and minus 4. Then 1, 2, 5 and 0. Matrix B is given as 1, minus 3, 2 and 7, 5 minus 6, 3 and 2 by 4 matrix. Here also we can see 2 by 4 matrix. If we are performing the this matrix addition, then these are confirmable for matrix addition. It is because the order of matrix A and order of matrix B are equal. Therefore, if you add these two matrices, then this will result If you add the corresponding elements, 2 plus 1, then 8 plus minus 3, likewise 3 plus 2, minus 4 plus 7, then 1 plus 5, 2 plus minus 6, 5 plus 3, 0 plus 1. If you perform this addition, then this results 3, 5, 5, 3, 6, minus 4, 8, 10. This is a 2 by 4 matrix. And the next important thing on the matrix addition is this. If you look back on the algebra, we can see that if you are adding 2 plus 3, this will be equal to 3 plus 2. Therefore, generally we can say that a plus b is equal to b plus a. In generally in algebra, we have this equality. For the matrices also, we may have that equality if we are having matrix A as A, B, C, D and matrix B as P, Q, R, N, S. Then if you check for the addition of A and B, this will be definitely equal to addition of B and A. Therefore, we can simply say that A plus B is equal to B plus A. This is similar as the algebraic addition. Therefore, we can see that A plus B, it is because if you are adding the corresponding elements, again we are adding the numbers. Therefore, this equality is satisfied for the matrices as well. Then if you see on the third one, in this third example, it is given as if A is given as 1, 2, 4, 5, 0, minus 3, having the order 2 by 3, and B is having 1, 2, 6, 7, 8, 0, 3, 2, 1, 3 by 3. If you ask to find out the value for A plus B, first you have to check whether the matrices are in same order or not. If it is not satisfying, we are not going to perform the calculation thereafter. Here we can see order of the matrix A is 2 by 3, order of matrix B is 3 by 3. These are not the same order, therefore we cannot, this A plus B does not exist. We cannot perform these matrix additions. And now we will focus on the subtraction of matrices. Subtraction of matrices. If you see the next part on subtraction of matrices, we may find that two matrices can be subtracted if and only if they are of the same order. A matrix of the same order is obtained as the difference of two matrices by subtracting the corresponding elements. It is quite same as the matrix addition. The only difference is instead of addition, we have to perform the subtraction. Therefore, the first condition is order should be same. The matrices should have the same order. If the matrices are in same order, we are saying that these matrices are confirmable for matrix subtraction. Then subtract corresponding elements. Then this results a matrix with same order. If you see on this example, if we let A is A, B, C, and D, and we let another matrix as P, Q, R, and S. If you consider this subtraction as A minus B, if you ask to perform this calculation, first you need to identify what are the orders of these two matrices. Here you can see that these two matrices are having same order. Therefore, we can say A minus B by subtracting the corresponding elements. B has to be subtracted from A. It is because B is the quantity that we are going to subtract from matrix A. Therefore, we will get this as A minus B, this as B minus Q. Here we will get C minus R and D minus S. This is how we are getting the matrix subtraction. And if you see on the looking on a numeric example for this, we'll say let A is matrix having 2, 8, 2, 4, 1 and 8. 2 by 2 matrix. Matrix B is given as 1, 2, 0, 4, another 2 by 2 matrix. If you ask to perform A minus B, first we need to check whether the matrices are in same order. Since these two matrices are in same order, then we can subtract the corresponding elements. Then we will get 2 minus 1, 4 minus 2, 1 minus 0, and 8 minus 4. Therefore, we will get here 1, 2, 1 and 4, 2 by 2 matrix as A minus B. Now, if you perform this calculation, if you see, if you need to get the value for B minus A. If you need to get the value for B minus A, then what will we get? B minus A, B is the first matrix and A is the laterally mentioned matrix. Therefore, 1 minus 2 will be used here. Then 2 minus 4, then 0 minus 1, and 4 minus 8. If you perform this calculation, then we will get B minus A is equal to minus 1, minus 2, minus 1, and minus 4. Another 2 by 2 matrix. Therefore, this is how we are performing matrix subtraction. And when you see on the matrix subtraction, now if you see on these two matrices, now see on this matrix what you have obtained as 1, 2, 1, 4 and the matrix here. Here we can see that these are not two equal matrices. It is because the corresponding elements are not equal. Therefore, in general, we can say that A minus B is not equal to B minus A. For the matrices also, the concept that we are considering for algebra is valid. It is quite as now in the algebra, we may have 2 minus 3 is not generally equal to 3 minus 2. It is quite as A minus B not generally equal to B minus A. For the matrices also, this inequality is valid. This is not equal quantities. Therefore, this is what we have to keep in our mind. Therefore, you cannot change the order of the subtraction, but for the matrix addition, it is quite okay. It is like this 2 plus 3 equals to 3 plus 2. For the algebra, we are defining this as A plus B is equal to B plus A. For the matrix addition also, we can use that equality A plus B is equal to B plus A. Therefore, this is what I need to discuss on this session, and thank you all for participating in this session.